Yo, what's good, guys? So today we're going to be going over essentially what position, velocity, and acceleration are, just in like any application in any course that you take, and like be it a physics course, um, specifically a calculus course, or a even like a chemistry course, to depending on how advanced you are. So this overview is going to be um, from a purely calculus point of view. Like, we're going to define position and velocity in terms of their calculus applications, much instead of their instead of their physics or chemistry um, definitions. There are some like minute differences. Moreover, like the calculus definition is more like applicable to the math that you would do in either physics or even calculus. And the physics definition is more about sort of like a synopsis of what is it, and it's more like about even like an app. It's more about like the overall application, like being able to like formulate equations based on whether or not you need acceleration versus velocity. So essentially, just calculus is the pure math of it, and physics is the overview of how it functions in terms of a system or like a circuit or anything of that nature. So position starting out, basically all position is it's just the location of something. So you can think of it like on a number line is how I like to think of position. Think of it as a linear. To start out, think of it as linear. Okay? So, we have a number line here. Okay, so this is 0, this is 1, 2, 3, and then negatives. Okay, so if our position is equal to our position is defined as x of t. T is a function of time, or well, this is a function of time essentially. This is the same as f of x, except here your x it's a function of x. This is a function of t. So this whole equation here, this x of t depends based on what t is equal to. So here would be an example. So say that you had like x of t is equal to, let me think of something, t squared minus 4t plus 5. Okay? This is what a position equation would look like. So say that you want to figure this out at 2 seconds. You want to know where is x located on this number line at 2 seconds. Okay? So what you want to do is you just plug in 2 for t. T is always in seconds. In physics, if you don't know this, there's the SI units. It's basically just a list of units that you use for basically every quantifiable thing. Like energy has like joule and stuff like that, and then kilogram is for mass, um, etc. But for time, we use seconds. So you want to basically just plug in what 2 here is. You want to plug in 2 for t, and this is equal to 4 minus 8 plus 5, which is 1. Okay, so at 2 seconds, the position is x equals 1, which is right there. Okay, so just think of position as like a number line, as a linear number line. In physics, what you'll most likely see is a Cartesian plane. Um, Basically just your standard XY plot. Um, and as you get more involved, you might look at like stuff like parametrics. In calculus, you look at parametrics, which is essentially just like, you have an X here and you also have a Y. So you have a position based on X, So here it would be 1, so you would go across 1 here, and then you would have another equation that would be y parentheses t, and maybe you plug in 2 for that, you would get maybe 5. So your point is up here at 5. Okay? But when you only have 1, you're only doing it based on like linear. You're only going across. There's no vertical motion. If you're taking multivariable or some even far like more complex math, you might have a different like a 3D plane, and you might be using a z and a y and an x. So that's that. That's position. It's just where it's located at. That's it. So velocity. Okay. Now velocity is from a calculus point of view, velocity is the rate of change in position. It is how fast and in what direction is something going from one position to another. Okay? So say I have a number line. Okay? Let's make this one bigger. Say this is 0. Say we're looking more at the right side of it. Okay? And this is -1, and then it goes all the way up to 7, and then you got all your middle ones in here. Okay, say that you start out at -1. This is where your first position is. This is where initially at 0 seconds, your particle starts out at -1, okay, on the number line. And then say you want to find what time is it at never mind. Say that later on it's equal to 7 at 5 seconds. Say that it's at position equals 7 at 5 seconds. Okay? So here this is your displacement. This is at the end of those 5 seconds, your total displacement here would be equal to 8. That's just a little thing that you need to know for finding velocity. Okay? So to find velocity, you're doing displacement divided by total time spin. So as we said, this to go from -1 to 7, it took 5 seconds, okay? So our velocity is equal to 8 over 5 in this instance, which is like 1.6 meters per second. When you're doing velocity, you're always in meters per second. That's another thing I forgot for position. This is always 1 meter. It goes back to the SI units. Velocity and speed is always in meters per second. Position is always meters, and then acceleration is always meters per second squared. But we'll get to that later. So your velocity is essentially how fast, or it's the rate of change in your position, essentially. Another way, the most common way that you would actually find this in most calculus, unless you're taking AP like Physics 1 or you're taking a algebra-based physics course, that's not, your Physics C or your college physics or calculus, uh, you would do like some method to find your velocity. You would most likely do this. You would do this displacement over time. Okay, but in calculus, there's another way that we can find it. It's with a little known thing as the derivative. So say that we go back up here, what was it? T squared minus 4t plus 5. Okay, so say that this is our position function. Say that the only thing that we're given is our position function and the time at which we want to find the velocity. Okay, so what we would do is we would take the derivative of this, which is just 2t minus 4, and we would plug in 2 seconds, because like, say that we want to find it at 2 seconds. We plug in 2 for t, and we get, what's this, 4 minus 4 is 0 meters per second. So at 2 seconds, it's not moving. It's like, it's not moving in any direction. It's basically stood still. So what this would look like is it would just look like this. If you know a little bit more, if you know a little bit of calculus, it's a maximum or it's a minimum. It's whichever one it would be based on doing all the other tests. But it's essentially just a sharp curve. So it's where the graphs goes from being positive to negative or negative to positive. Um, just based on the fact that that it's zero, that the derivative is equal to zero at that point. Okay, so that's essentially just how you find your velocity. You take the derivative of your position function and then you plug it in. Another thing that this is called, this right here, can be called instantaneous velocity. Um, it's just instantaneous velocity. All that means is that it's the exact point at which that it's the velocity at that exact time. So yeah, there is a for instantaneous velocity. If you look it up, there's a formula that involves like a limit. Like I'll look it up right now. It's like it involves a limit, and it's quite confusing because it doesn't really like make a lot of sense um in terms of like, yeah, it's what the limit is saying. If you've seen it in like any calculus textbooks or even your physics textbook, what it is saying is it's basically just the definition of a derivative. If you remember that, it was like the limit and then like h minus 0 or h minus it was just like it was your limit. It was your derivative definition. So don't mind the limit, just take the derivative and then plug in the point or the time that you want to find it. That's all you have to do to find your velocity at that point. Okay? Acceleration. Okay. Acceleration is the rate at which velocity changes. So this is not quite accurate what I'm about to say, but just think about it like this, okay? Position is where you are. It's if I'm standing down the street, that's my position. If I run up the street and I'm running at 5 miles an hour, 5 miles an hour is my velocity. I'm running down the street at 5 miles an hour. That's my velocity. If I run 5 miles an hour and then I run 10 miles an hour, that, me going from 5 to 10, that's my acceleration. That's how fast my velocity is changing. So, when people say, "Oh, the car accelerates to 60 miles an hour in 2 seconds," that's not saying that it has a fast velocity. That's saying that it has a fast acceleration because it's able to get to such a high speed from such a low speed so fast. So the speed at which something goes from a lower speed to a higher speed, or just any two speeds, is your acceleration. Okay, so your acceleration is, if you think of it as velocity is the derivative of position, because velocity is the rate of change in your position, acceleration is the rate of change in your velocity. So it's the derivative of your velocity, or it's the second derivative of your position. So say that back again, we go up, we have the t minus 4t, what was it, plus 5. It doesn't matter, I guess, but yeah, plus 5. Okay, so this is our position function. Okay, so when we want to find it at 2 seconds, I don't need the EC. The unit for seconds is just S. It's not EC like you usually see on like odometers and etc. and stuff like that. Okay, so you take a derivative to find your velocity. Okay, this is VT. Um, when you do, to like signify that it's a position function or a velocity function, you for position you just always put x or y because it needs to know what axis, or like what not yeah like what axis it's like affecting, if that makes sense. Like if it's going across the x-axis or if it's going up and across the y, up or down, that sort of thing. Velocity is just vt every time, and then acceleration is, take the derivative of this, is just at. Velocity and acceleration are pretty easy to remember. this is just dependent on whether basically you're going to be given this, and if you're not, just assume it's xt and not yt unless it's like a specific problem. Okay, so here, okay, so your acceleration here is equal to 2. Okay, so let me sort of explain what this exactly means. Okay, so say that I have a graph. Okay, I have a graph. I'll graph 2t minus 4. It looks something like this. It's really steep and it goes through -4. Okay, it's linear. Okay, it doesn't change what it's doing. It's doing this. It's growing at this rate forever. Okay, it's never not going, 2 up, 1 across, or 2 up, 1 across. It's never not doing that. Okay, so it's not like a car where it grows exponentially faster once it like. Okay, think about it like this: when you're at 0 miles an hour in a car, it's harder to get to 30 miles an hour than it is to get from 30 to 60 miles an hour, and then it's harder to get from 0 to 30 than it is from 60 to 90 or 90 to 120. The faster you're already going, generally the easier it is to make yourself go a little bit faster because you have force behind you that will propel you forward. Okay? So say that this was t cubed. Okay? So this acceleration is constant. Every time you have a square, it's constant. Every time that you have only, a linear function, you just don't have an acceleration. Okay? Okay. So say that I had t cubed minus 4t plus 5 is equal to, let's do this, t cubed minus 4t squared plus 5t minus 6 is equal to x of t. Okay? And I want to find this at 2 seconds. I want to find the acceleration at 2 seconds. Okay? So here's what I'm going to do. I'm just going to take the derivative. So 3t squared minus 8t plus 5 is equal to vt at 2 seconds. And I'm going to take I'm just keeping the at 2 seconds just so I can remember to plug in 2 at the end. 6t minus 8 is equal to at at 2 seconds. Okay, so you notice that this is not a number like this is up here. This is something that will change depending on what time it's at. Okay? So at 2 seconds, this acceleration is 12. At any You obviously cannot have at 5 seconds you can't just have 5t minus 8 acceleration. That doesn't make sense. You need to plug in 5. You need a number. Your acceleration has to be a number. Okay? So what this essentially means is that I don't know what the graph for this exactly is. You can if you have a graph calculator, you can graph it, and you can kind of see how the higher you go, or the further along the x-axis you go, the more it grows up, like the faster it grows. A good example of this is, I believe, if I remember correctly, and I'm not getting it wrong, e to the x will grow. Yeah, e to the x. E to the x. Okay, when x is equal to 1, e to the x is just e. 2, it's a lot bigger, but it's still relatively small. 3, but then all of a sudden you start hitting 8, 9, 10, and it just goes way up. It just goes way, way, way up because it's gone up. It's gotten to a point where the numbers start to increase by so much on top of each other that it's just it's just changing so fast in that short amount of time. So that's kind of what your acceleration would look like. In fact, you can even find the acceleration of e to the x. If you know how, it's actually quite interesting. The position of e to the x is just e to the x, because that makes sense. The velocity of e to the x, the derivative of e to the x is still just e to the x, so velocity is still e to the x. Acceleration, once again, is still just e to the x. So your acceleration is increasing by e to the x. So if you're at 9, your acceleration is e to the 9, which is insane. That's a crazy acceleration. So that's essentially what it is. Acceleration is the rate of change in your velocity. Another, like, let's just solve this at 2 seconds. This is 12, or not 12, 4 meters per second squared. Um, that's just the meters per second squared is the unit that you use. It's every time that you have acceleration, meters per second squared, every time. Um, unless like the question is in feet, but I mean, if your teacher is giving you questions in feet, then I would be surprised, because that's like, your teacher, that's like your science teacher making you use Fahrenheit, honestly. It's not the correct unit that you would use. But yeah, this is what you use. You always have a second squared when you're doing acceleration. This like length can kind of change, but it should mostly just be meters if you're taking a respectable course. Um, so yeah, kind of know that when it's like this, when you have a constant acceleration, that means that the velocity is just increasing at a linear rate. Um, and then know that position for the most part, unless it's parametric, is just linear, and it's just uh, across a horizontal line. Know this if you're not taking a calculus course or a physics course with calculus, because this is, I'm pretty sure, how you would find it. I've never taken a physics course that's not algebra, 'cause it's kind of a waste of time, but this is how you would do this. You would All this really is think of this as rise over run. It's like, let me make this even more hard to decipher and do this. Okay, so you have it goes from x equals 5 to x equals 10 in 2 seconds. So you take the difference, you do 10 minus 5, and then you do it over 2. That's really all it is. It's the difference between the um end position and the beginning position, and the total time that it takes. Um, some more nomenclature that you might need to know. That's pretty much the gist of it. But like, if you don't know what if a teacher writes X initial, V initial, or even A initial, uh, these are just your and it's like, find these. These are just the starting times, or the starting, velocity, position, acceleration, when it's let go. If you're taking a physics class, this is important. Um, you might also see them as that, or this. Um, depends on the teacher. Some use this, some use this. Most of the time, if it's velocity, you're gonna see it with a 0. If it's if it's a position, you're gonna see it with an I, and you know, your best guess. It can go either way. You really don't see acceleration initial that all that much. You mostly just see velocity and position. Um, Another thing is, this is just final. The F is just final. Um, so yeah, that's pretty much that for position, velocity, and acceleration. It's really not that hard to grasp. It's more or less just looking at your problem and being able to decipher it. If you can figure out what the problem is asking you, you can just set up a million of these. You can just run through them, because they're like all really similar. All the word problems are really similar. If you can just get them under your belt and figure out what the similarities between all of these problems are. So yeah. Hope this was helpful.